Hi. In this episode we'll be using JavaScript to produce prime numbers. We'll be doing test-driven development in Node, and we'll prefer const overlaid over var as usual. We'll have an opportunity to use default parameters. We'll always have automatic linting. We'll use Mocha for testing and Chai for expectations to drive our code with failing tests first. We'll use arrow functions as normal. We'll get an opportunity to do some refactoring. We'll get to use a while loop. And one of the requirements for this exercise is that we'll use recursion, just to make it a little bit more fun. So let's get started. Okay, let's get set up. I'm going to share this setup between all of my exercises to make it a little bit easier. So let's get going. So I'm going to create a directory to work in, app. And you see our Explorer here is keeping up with us. This is VS Code. I'm going to go into that directory, and I'm going to use Node, so I'm going to create my package.json file. There it is. It's a simple template. And let's start installing the tools I'm going to use. And they're going to be dev tools. So first of all, for testing, Mocha and Chai, Chai for expectations. And then ESLint and ESLint plugin Mocha, because I'm using Mocha. Alright, and then one final thing while I'm at it, I might as well install NYC for code coverage while I'm here. It's a successor to Istanbul. Okay, good, so that's the three of those. You can see our package.json file. It's got our dependencies. It doesn't do anything with our test command yet, so I need to fix that. But first of all, let's copy in this ESLint RC YAML file that I've got. And you can see here, there's a ton of rules. I love having loads of rules to guide me, you know, in errors and warnings. So it's very, very handy. I love that. Alright, that's the ESLint YAML file. And here's our scripts where we want to actually put in running tests. So let's put in the actual command we're going to use, which is going to be Mocha. We'll just use the top level, anything that's called star.test.js. Okay, so we should actually be pretty close to be able to run tests. Let's try to do it with npm test. And no files found, but no actual error. So let's go ahead. We'll use index because that's what the auto generation of the package.json used. And we'll put in our index.test.js, which is actually the file it'll recognize. Alright, so it's green. No test, but the framework's there. Alright, so let's put in the other pieces now. Let's put in the linting, which is going to be our pre-test, so it's going to run before the tests can even run, and that's going to be ESLint everything. And while we're here, let's put in our code coverage, and that's going to be the NYC npm run test. So that's close to all of the pieces we need. We can run our tests again to make sure that they work, and we can run code coverage to make sure that that works. And you can see that we didn't have any files again, but this is the expected output that we've got. So we've got our linting, our testing, our code coverage, our basic files set up here, NYC output for code coverage output. So we're pretty much ready to go. So now we can go ahead and create the actual app. Okay, so let's start off with our our index and our index.test.js files. And let's write the test first, of course. So let's include our testing library here. We want to be able to use expects from Chai. So we'll require the Chai library. Oops, Chai. There we go. And we want to pull in our code file above. So we're going to call it primes, and we'll use require to pull in that, it's called index, of course, a file name, just to be standard for these exercises. Alright, let's write a test. So, alright, let's try and write a good definition here. So we want to produce a list of n primes, and we're going to say using recursion. We wouldn't normally specify something like that, but that's specifically what this exercise is intended to show for the purposes of the exercise. Alright, so our first example, let's try and get it as simple as possible. Absolutely as simple as possible. Let's get the first prime, which is the number 2, and get our function to return that. So our expectation would be that when we call this function we're going to create, and we pass in, tell it to give us one prime, we expect to get a result, which is the number 2. So that's about as simple as we could get. And let's go ahead and write the code. Start writing the code that'll fulfill this. We want to use strict, and in fact we want this in this one down here as well. So let's add that back in, add it in here. It's going to help guide us, make sure we have good code. Alright, that should be a standard. So we follow it. Okay, so now we're going to use exports. We're going to create this function called primes, which we already named below. We're going to pass in, we know we're going to pass in how many, so let's just put that there while we're aware of it. And let's try and make that test pass by returning 2. So let's see if that's as simple as we can do to make it pass. Missing semicolons, need to got our linting going to keep us on the good path there. And how many is defined is not used, of course, because we're trying to do the simplest thing we can. So we can get rid of that for the purposes of this test. I don't think this one's saved. Save that, right. Okay, this is better. Primes is not a function because we haven't used the right format here. We're going to require it this way. We have to surround it with braces. Alright, so let's try that. Okay, expect is not a function. We forgot the .expect at the end, so let's put that in. Okay, simple mistakes. Alright, we've got something going. Our system is basically up and running in terms of the test framework. So we can always make one case pass like we did. So now let's force it to have some code. So let's get the first 2 primes, and that should give us well, 2 and 3 in some fashion. So if we say give us 2 primes, the result should be, okay, well we're going to want an array when we start having multiple numbers like this. We're going to return that from the function. So let's make sure that fails, because of course there's no code here other than the hard-coded one. So let's add some code now. So what do we want it to do? It's a little bit tricky with primes to try to break this down, but we're going to have this array, so we know we're going to set that up. And let's think how we're going to do this. For loop might be good, but we kind of want to stop as soon as we get a number, and I've been using a lot of while loops for that lately. So because we just want to keep going until we get to this how many we've requested, how many was passed in as a parameter, and then we want to do some kind of is prime. If it's prime, we want to add to the array, which is a push, and a brace, and then we want to return that primes array. So I think this will work if we use the length of if our length of what we've collected is not yet reached how many we want, then let's actually make this a real, when we check if it's prime, we'll write that in a second, of the number we are currently looking at. Let's go in for a second. So if that's true, then we push this onto the array, that number. Okay, so that's kind of what we want. This is not formatted correctly right here. Let's see. Yeah, missing paren, and we're actually missing a closed brace. Okay, let's add that on. Semicolon. Okay. So I think that might be the code that we want. Let's try that out. Reachable code is interesting. Come back to that in a second. But I'm missing semicolon as well. And let's put this function in here that we haven't defined yet. Maybe that's the unreachable code. So this is going to be our little checker here. We'll start off with a simple condition just for the test that we're doing. We'll say, well, we can make this work with this. It's not going to be the result, but that'll make the test pass. Okay, so let's see if we've got our, yeah, okay. I think, and we'll do our triple equals. We won't even wait to get warned about that. So that function calls this function. Let's see if that works. I've got missing semicolons. One here. And let's see. Those ones are alright. I think if we could. Still getting unreachable code. And you can see it's. Our editor has actually dimmed it all out a little bit here. And then we can spot why. Let's see. We also want to keep track, while it's in my mind, of our current number that we're doing. So that's going to be 2. Our current number is 2. Let's have that instead of n. Current number. Current number. Okay. Oops. Didn't let my editor help me there. Yeah, there we go. Okay. Lining up. Alright. So we're keeping track of this current number and we're pushing that. And we need to increment it as well, so let's put that bit of code in here. Instead of plus plus, I use plus equals 1. It's a little bit a better approach. Alright, let's try that. Still got unreachable code. And look at that, we got a return statement right at the beginning. No wonder it was grayed out. Alright, how many is not defined? So what's going on with that? Well, we didn't actually declare the parameter. So there it is, there's how many. So let's see how that looks. And something's not quite right working here. Let's see. Not quite sure. Let's try running this test only. Something we can do here to see if this is where the issue is. And we're definitely getting some problem here. Expected 2 to equal 2. Oh, we can fix that. That's a familiar one that I've become used to. And we see here exclusive Mocha test. That's fine. That's because we're doing it. So this should have been an array. So let's get that to an array. Make that pass. And it's using equal, but we actually want EQL. Shallow versus deep. Alright, so that's passing now with the it only, which is good. Let's just try it without the array. Okay, so it does need those. Sometimes I've seen it, some examples pass without them for different code. Alright, so that's passing. We'll get rid of the only now. So run all the tests again. See if the second one will pass. It's still hanging. Let's see what's going on here. So this code is not doing what we want, I think. So we were just dealing with the first prime, which was 2. Now we want to actually start having some code. We want to see if the number's divisible by something, by our div here. And if it's exactly divisible, then we want to return false. Okay, so we've got this, let's put a space in there. Now we've got this div, we're going to need to define that, but let's just write div is not defined. There you go. So we're going to divide by, we're going to go through and keep dividing by different numbers. So this is going to be passed through. This is where we know it's going to be recursive. We're going to set that to 2 to start with. And we divide by that, let's run that. Passes but hangs. So there's still a bit more work to do here. So we need to change the div, the divider, as we recursively call this. So let's set that up. And let's not mutate our parameter. So let's create a new variable called new div, a constant, and recursively, in this case here, call this with that next div. So we'll go through dividing by all of the numbers. And next div, spell it right, get the right name, okay. I think that's good, let's try running that. Oh, okay, get stack trace here. Something's not quite right. So let's see, several conditions here. If it's 2, if it's 0. We need one more condition here, pretty key one really. This is where we're actually going to start doing some of the logic here. If we've reached the end of the series, nothing has been divisible, I mean, we keep recursively calling this, and our divider has reached our maximum number, then we want true. So let's see, 2, 3, and that's almost there. We just got to get this one also to be EQL. Let's fix that. Okay, our tests are passing. So that was good. I think we can immediately refactor this. This is a little bit ugly, so we can make that a one-liner, make that a one-liner, make that a one-liner. And not only can we make them one-liners just by pulling all the pieces in, still passing. We can actually we can simplify some of this. We can get rid of this brace here, and this one, and the end ones, this one, and this one. And still passing, yeah, okay. And well, both of these do true, so maybe it will be more readable. Let's try it out. If we just do an OR statement, so if the number's 2, which is often a special case with recursive, etc. algorithms, if the number's 2 or the div is number, we reach the end of it, then return true. So those are combined. So that's pretty good. Now I can move on and do another test. So let's do a test of, let's think, let's copy this, let's be lazy. So let's do the first 4 primes. So 2, 3, 5, 7, just to make sure that our routine is working as expected here. So expect prime, so the 2, 3, 5, 7, and that's 4. So let's run that and see what we get. Nice. Alright, so let's jump ahead to something a little bit different, because we're getting odd numbers right now, so let's be a little bit more adventurous, and let's get a bunch of primes. Let's go all the way up to, let's see, we should skip 15, we should skip 21, 3 7s, so let's make sure all that fun stuff is happening, and it's not just giving us odd numbers. Alright, so let's try running that. Give us 9 primes. Okay, that's those. And first 9 primes. Okay, let's run that. Nice, so all of our code seems to be working here. Let's see if there's anything we can refactor. Looks like this could just be a one-liner, so that'd be kind of nice. Yeah, that's this, yeah, and then let's see, we can get rid of that line too. Looking pretty good. There's our code. This is fairly simple. Let's run it. Oh, thought we were done, and we actually introduced an error. Always run your code. So it's a linting error. There's a space at the end of the line there. Alright, so all of our tests pass, and our code is done.